Alhamdulillah. I'm very fine by the grace of Almighty. So Ziba was asking about Fleming's right hand rule and left hand rule. Where we use which one? Do you know, Aisha?
Fleming's right-hand rule we use for electric circuits and like for anything with electricity, maybe. And left-hand rule we use for anything with magnetism, electromagnetism. Maybe.
Okay, so you take the notes now. Fleming's left hand rule we use for motor, DC motor. We discussed that one. And here we are getting kinetic energy from electricity. Can you note down, please?
Kinetic energy from electricity.
Yes. Yeah, right here. Fleming's. I'm writing Fleming's left hand rule. That is using DC motor. We discussed already. We get kinetic energy from electricity. Okay, this is Fleming's left hand rule. And another thing you add here, like we did in electromagnetism, we did it in electromagnetism. Topic 22. Topic 22. So this is for Fleming's left hand rule. Now we are doing Fleming's right hand rule. Fleming's.
Assalamu alaikum, sir.
Wa alaikum salam, Adnan. You joined today as Ahsan.
ও আচ্ছা, নাম চেঞ্জ করতেছি, সমস্যা নাই।
Yeah. Fleming's right hand rule, Fleming's right hand rule we are using for generator, generator. That is opposite, we get
এতক্ষণ কি করাইছেন স্যার?
We are discussing about the difference between Fleming's left hand rule and Fleming's right hand rule. So you check, it's written. Yeah, write it please. Fleming's right hand rule we are using in generator. We get induced EMF or current from kinetic energy. Okay, I'm writing details. So we are getting this discussion in electromagnetic induction. Electromagnetic induction. It is topic 23. So Dan, I think you got the basic idea, holistic basic idea. So Ziba, Aisha, Moshi,
Yes, sir.
you understood my writing?
Yes, sir.
Yes, sir.
So complete it,
শেষ লেখা।
This one, huh?
Assalamu alaikum, sir.
Walaikum salam. Yakin, we are missing you for a couple of days. Take this note, huh, Yakin?
Yes, sir.
Quickly. This is topic 23, huh? Topic 23. Finish writing, huh? Then we are going to the rest part of topic 23.
Yes, sir. I finished writing.
Okay, very good. Look, we are having here topic 23 learning outcomes, and we did A, B completely. Now C we will do today. See, little bit we started in last class. Now we are going for discussion. This is Lenz's law, huh? And I told you this is the basic of alternating current. And that day I discussed what is the difference between the DC and AC, direct current and alternating current. So we will get here now the discussion. Lenz's law. Huh? Lenz's law, it is the application of whatever we learned till now. Huh? At the beginning of today's class, when Ziba was alone, that time I mentioned one rule, that is right hand grip rule. And right hand grip rule we learned in topic 17, that is magnetism and electromagnetism. There you got right hand grip rule, and also we got the application of right hand grip rule in topic 22 for wires carrying current, straight wires or straight conductor. Can you remember that one, all of you? Hello, can you remember that one?
Yes,
That
sir.
we had one conductor, like a single conductor taking the current upwards. We are having magnetic field around it, huh? And it is followed by right hand grip rule this way, and it is anti-clockwise. Huh? If you use your right hand, make the grip of right hand, then you see the thumb is showing you the current direction. This is current direction I. You see I gave one arrow here, and these circular lines showing you magnetic field lines. Okay, if this wire or the conductor is not straight, and it is like coils, it is like solenoid, then how these magnetic fields are produced? We did it in topic 17. Now again I am showing you, you just have a look, because it is really needed to understand Lenz's law. Okay, look, can you see the diagram?
Yes, sir.
Yes, sir.
Okay, please, without hand you just draw this solenoid. You see there is north and south produced. You show the current direction correctly, and look, it is also followed by Another way of application, right hand grip rule. Here we are having the current direction for the other fingers, and thumb is showing us the direction of North Pole. Okay, so you draw this diagram, then you write at the caption, right hand grip rule application for solenoid. I'm writing the caption. Right hand grip rule application for solenoid. So look how the current is flowing. It's flowing.
আবার একটু আগের মতো করেন।
Which one?
ছোট হয়ে মানে পিকটা ছোট হয়ে গেছে, বড় ছিল, একটু আগের মতোই রাখেন।
ঠিকই তো আছে, চেঞ্জ তো করা নাই স্যার।
I did not change.
আচ্ছা হ্যাঁ আমারই হয়েছে, হ্যাঁ।
I did not touch the diagram.
And then internet problems, unstable probably. Sir, instead of the hand, what do we draw?
Yes,
Instead of the hand, what do we draw?
you just give here or label here thumb. If you can draw, it's nice. I told you not to draw because you will not be able to draw. If there is happening also for me, I cannot draw the hand. So if you can draw, then you draw it. That will be nice. Otherwise, you label this one is thumb, and here is other
Okay.
fingers.
Okay.
Other fingers are showing you current direction, and thumb is showing you North Pole. What I can't do, I don't force others to do.
স্যার ডান।
হ্যাঁ হ্যান্ড ওয়ার্কস একদম ভালো মতো। এখন ডায়াগ্রামটা কি?
Sir,
Yes,
Sir?
please.
In this solenoid, in this solenoid that whole thing is the magnet, right?
Look, this one.
No, that pole is the is it iron or aluminum?
This is iron. This is iron. Actually, if you want to write, you can write here. It is electromagnet. Now,
Okay.
electromagnet is a temporary magnet. Once you are passing the electricity, then it is magnet. We are using here iron core. Inside the solenoid, we are using iron core. That iron core is turning to electromagnet. Okay.
Okay, but sir, what other iron? No, what other cores can we use? Like, what other metallic cores can we use alongside iron?
Okay, so mechanical force, I don't understand what you are saying.
So, metal cores. Like,
Yeah,
for example, here we've used iron. Can we use some other metal?
No, normally we use here iron because we don't want this magnet to always work. Okay, this is temporary magnet. When we need it, then we pass electricity and we get the magnetism. Okay, you know there are only 4 metals which are producing magnet or magnetism. Those are called magnetic material. What are those 4? Iron, steel,
Iron, nickel,
yeah, nickel, cobalt, and steel.
steel, and cobalt. Yeah.
Yes, so out of these 4, only iron is soft magnetic material. Which one we can use for making temporary magnet? Other 3, those will be permanent magnet. Okay, here we want to have
Okay.
temporary magnet.
So they will become permanent magnet if we place them inside the
Solenoid.
solenoid.
Yes, yes.
Oh,
So is it done? If you're done, then you let me know. Huh?
Yes, sir. Done.
Yes, sir, done.
So if you are done, then we are going to Lenz's law. Can you please write the heading? I think some of you wrote the heading, Lenz's law. Now we are going to discuss it. Afterwards, you write the law. Once we are done with the discussion, then you write the law. Look, here we got uh, Faraday's law of induction. You already got. There you got, if a magnet is taken towards the coil, then we are getting here induced EMF, right? In the coil, we are getting induced EMF, and we can see the deflection of the needle. Huh? Now we are adding here something more. Like when we are taking this magnet over there, we are getting the EMF. That EMF is producing current, isn't it, in the coil? Please, if you agree, then say yes. Otherwise, you say you don't understand.
Yeah.
Yeah,
Yeah.
then I can go to the next step. In our
That's just
previous,
creating kinetic
yeah,
energy, right?
in our previous discussion in Faraday's law of induction, we got, if you are taking the magnet towards the coil, then you are getting current. Do you agree? You are getting,
Yes.
yeah, induced EMF or induced current you are getting. So if you are getting current over there, then according to right hand grip rule, as we are getting current in the coil, we will get one magnetic field produced. Do you agree?
Yes.
Because just now we discussed that if current is flowing through the wire or coil, then we will get magnetic field, isn't it? Hello.
Yes, sir.
Okay, now you check here, the direction of the current here is given. Look, these small arrows are showing you the direction of current. The current produced due to induced EMF. And if you apply now right hand grip rule, just now you learned that one. If you apply, then you will see here left side we will get north pole and right side we will get south pole, isn't it?
Yes, sir.
So this one is actually crucial. You have to be very much, careful to understand it and very much attentive. If you lose one point, then you will not link. You cannot be able to link with the other one. Look, so here we are getting south pole, right? When we are taking the south pole of this magnet, then we are getting here another south pole. Okay. This south pole comes due to the induced EMF by applying right hand grip rule. So when you are trying to go more inside of the coil, like more closer to the coil, this induced south pole is not letting the magnet to go more forward. It's opposing its motion. Is it clear?
Yes, sir.
Yes, sir.
Okay, so what you will do if someone is opposing the motion, you must take out the magnet, right? You must take out the magnet. So when you are taking out, then your direction of magnet is opposite, right? The way you are going towards the coil, now you are going away from the coil, isn't it? Hello?
Yes, sir.
So when you are taking away the magnet, that time what happens? We are getting opposite pole. Previously we got south pole. Now we will get what? Opposite pole.
Opposite.
That means we will get here now north pole. And that north pole will not allow south pole to go more away farther. Like it will now attract the south pole. Is it clear now?
So the direction of current will also change when we move
Yes,
away the
yes,
magnet.
yes. That was the step before getting the north pole. Direction of current changes. That's why you are getting the north pole. Is it
Okay, okay,
clear?
sir. Yes,
Because
sir.
this north pole or south pole produced beside the coil, we are getting due to the induced EMF, right? So when we are getting here north pole, of course the direction of current changed. That's why according to right hand grip rule, we are getting the north pole in opposite side. Is it clear now?
Yes. Yes,
Yes.
sir.
Okay, so in our last class, when I was explaining Aisha's question about the AC and DC, that time I told you that Lenz's law is the basic of AC, right? Alternating current. Look here, when we are taking the uh, magnet towards, we are getting the current in one direction. Then when we are taking away, we are getting the current in opposite direction, right? So here we are also getting the basic of AC, alternating current, isn't it? Because the magnet's movement, you are doing it forward, backward, then you are getting the alternating current. Are you clear how alternating current is produced? Hello? Hello?
Yes.
Yes, sir. হ্যাঁ
So that's why I told you that this is the basic. There are more advancement when we'll discuss the generator part. That time we will understand it more. But it is the basic. Lenz just brought this idea. Okay, and because of his this explanation, we could reach there in AC generator. Okay, so we understood 2 points here mainly. That is from from this position, if the magnet is taken towards the coil, that time we are getting here south pole, which is not letting us to go more forward. And when we are taking away the magnet, that time we are getting here north pole, which one again not allowing us to go more away further, right? So this process is a continuous process. It's happening, yeah? Continuously. The magnet will go forward and backward. Yeah? This process will continue. So if you can, make one arrangement like that, then it will be continuously. It will go on. Yeah? Spontaneously, it will go on. Now there is another diagram. Look. The one I just discussed with you, that one is done here. In the third diagram, look here, the magnet is taken away. That time we are having here north pole, and this north pole is not allowing the magnet to go more further. Okay, so we got this idea. Now we are having another idea. When the magnet is not moving, it is a fundamental condition that to get induced EMF, there should be movement. In our today's discussion at the beginning, I told you that in generator or Fleming's right-hand rule, we are getting electricity or induced EMF from the kinetic energy. That means we need the movement. If this magnet is not moving, that means the magnetic field lines of this magnet are not cut by the coil. It is a must. It is a must that magnetic field lines should be cut, or in other way around, we say change in magnetic flux should be happened. Then we can get this induced EMF. If the magnet is in a place is stationary in rest position, then we will not get any induced EMF. Is it clear? Is it
Yes,
clear,
sir.
So
everyone?
can
Yes,
you
sir.
explain it again?
Yes, I am explaining because here I brought two things more. You might not present when I discussed magnetic flux, change in magnetic flux. Okay, here you see when the magnet is, beside this magnet there is thousands of magnetic field lines, right? And
Yes, sir.
those magnetic field lines will be cut by this coil if the magnet is moving. Either you have to move the coils or you have to move the magnet. Okay, then we will get the magnetic field lines
Right.
cut. And in
Magnet.
other way around, we say it, there is change in magnetic flux, because you are taking it more closer to the coil, you are having more flux density inside the coil, right? And it is changing, frequently is changing, and because of this change we are getting the EMF. If it is in one place stationary, we are not getting change in magnetic flux. That's why we are not getting any induced EMF. Is it clear now, Yakin?
Yes, sir.
Okay, now this only. Okay, whatever we discussed, we have all the points here. So I think you can write the Lenz's law now. You write the Lenz's law. Look here. Here, this is authentic one. I am writing. I prefer this one because it's in Cambridge. The statement written here. From here you will write the direction of current. From here you write. You write the heading Lenz's law. Then from here you start. The direction of a current produced by an induced EMF opposes the change producing it. Okay, till here you write. Till the Lenz's law. Are you writing? Hello.
Yes, sir.
Are you writing?
Yes, sir.
Please write it. From here I am showing you. From here, the direction to here. You write the heading Lenz's law, then you write the statement from here to here.
Done, sir.
Yes.
লিখবো স্যার এই
This
স্টেটমেন্টটা।
one you write the heading Lenz's law, and it is the statement of Lenz's law. Whatever we discuss till now
আচ্ছা ঠিক
about
আছে,
the
লিখতেছি।
Lenz's law, it is the sum up. And you also relate the discussion you just got and with the statement, is it matching or not? If you have any question, then you can ask me. You should memorize it, because in
Yes,
some
sir,
of,
done.
yeah, in some of the papers it is coming, this statement is coming. Okay, now you have to draw this, huh? You have to draw these 3 diagrams, huh?
পাশে কি নোট লিখবো এটাও একটু লিখে দিয়েন স্যার।
Yeah, I will tell you, huh? Just you draw first, then I will tell you in short. It is also written here, huh? It is also written here, but I will give you in my words. No problem. Already I told, again I will repeat, no problem. For this one, I am writing first. Okay. When the magnet is taken.
ড্র করতে হবে স্যার।
Yes, you have to draw it. Otherwise, you will not understand, my dear. And you, when you are drawing, you must show
একদম
the,
নিচে একটু 1 সেকেন্ড জানতো
1 second. I am writing.
নিচে না নিচে স্যার নিচে থার্ড ডায়াগ্রামটা একটু দেখবো সে অনুযায়ী করে ম্যাগনেটটা
আরে
আঁকবো
স্যারের
ফার্স্ট
লেখা
ডায়াগ্রামে।
শেষ হোক, এরপরে যাক স্যার।
Now I
লেখা
have
শেষ
to
করি।
rewrite.
নিচে নেমে উপরে উঠলে তো সমস্যা নাই।
Okay, look.
হ্যাঁ স্যার উপরে চলে যান।
Okay. When the magnet is taken towards the coil, then due to, I am trying to make it shorter, due to induced EMF, in bracket you write current, south pole is produced closer to magnet. Magnet according to right hand grip rule, grip rule, which does not allow the magnet to go more forward. Okay, so it is about the first diagram, huh? And right after this first diagram, you draw the third one. Yeah, that is figure 23.6. Then you will write the description of that one, which one is opposite of it.
কি বললেন স্যার, কোনটা অপোজিট?
So you will draw now, and after you are done with this drawing and writing, then you will draw this one, the third one, huh? This one.
সেকেন্ড আঁকবো না?
That one will draw later. Okay. So you draw it
এঁকে
first.
ফেলছি।
Okay,
স্যার
fine.
সেকেন্ডটা তো আঁকা লাগবে না, ফার্স্ট এরটা আর থার্ড এরটা, তাই তো?
Yes, first one and third you draw first, then this one you will do later. Okay. Second one you will do at
একটু
last.
নিচে
এটা আঁকা লাগবে না।
Sir,
Third
we
one,
can draw one and একটার মধ্যে ডান সাইডে নর্থ পোল দেখালাম, বাম সাইডে সাউথ
yeah,
পোল
that
দেখালাম।
one will make your drawing more clumsy. I don't know, you can understand it later on clearly or not.
স্যার যেটার উপর সার্কেল ওইটা আঁকবো না, তাই না?
You have to draw it
মানে
now.
ওইটা আঁকবো।
মানে
Yes.
সেকেন্ডটা আঁকবো।
হ্যাঁ,
You
আপনি তো বলতেছেন সেকেন্ডটা আঁকবো না, এটা তো
which
সেকেন্ডটা।
one
এটাই তো।
which one you meant
ও
6
আচ্ছা,
second?
তিনটা
ও
একবার
আচ্ছা এইটা সেকেন্ড। আল্লাহ,
শেষটা আগে রাখবা।
Look, we drew this one, right? 23.4.
হ্যাঁ
Okay,
Yes, sir.
now you will do 23.6.
ও আচ্ছা, মাউস এমন ভাবে গেছে যে
Okay.
আদনান খালি ঝামেলা বাজায়।
একটা কানের নিচে লাগাবো।
Okay, now you draw 23.6. And for this one you will write just opposite of the one we wrote just now.
অপোজিট মানে
Like you wrote here, when the magnet is taken towards, right? Then what you will say, when the magnet is taken away, right? Away from the coil.
স্যার মিটিং না এখনই বন্ধ হয়ে যাবে, আরেক মিনিট আছে আই গেস, পরে ক্লাসে করি।
So can you write this? Finish
স্যার
writing.
পরে ক্লাসে লিখেন, স্যার পরে ক্লাসে লিখেন, মিটিং যে কোনো টাইমে বন্ধ হইতে পারে এখন।
Okay.
এই মিটিং টাইম আছে কিন্তু ক্লাস শেষ হয়ে যাবে।
Okay.